Hello, this is Chongyang. I will present you our work, PepperPose, full body pose estimation with a companion robot on behalf of the team. This is a collaborative work between Pervasive Human-Computer Interaction Laboratory at Tsinghua University and AIS at Chinese University of Hong Kong, Shenzhen. Please kindly refer to our website for more relevant information. In the next, I will first give a brief about our motivation, and then dive into the method behind PepperPose. Finally, the results, together with a video demo that shall give you a clear picture about how PepperPose works. It is obvious that we live quite dynamically in our everyday life. In terms of the locations, our activities span across different rooms at home, and we also take considerable time outside. Furthermore, the actions we involve, either for exercise or for daily functioning, are pretty diverse. Given such circumstances, capturing the pose of people becomes very challenging, especially when we expect such technologies should be merged into the daily life of our users. In the past, we have seen a growing body of works that explore this exciting area. However, the following limitations still impact their efficiency as well as sufficiency in open and real-world settings. For external devices like the wearable and more recently the wireless sensing methods, the users are normally required to stay in a certain area. While for the wearables, maintaining the balance between estimation accuracy and user comfort is always a headache. More importantly, most of these methods do not consider providing interactivity to the user and merely become the sensing device in the inner circle interaction design. As a researcher myself, who worked with action sensing interaction in past years, I have always been thinking about how to tackle such a bottleneck in front of us in providing flexible, comfortable, and interactive post-estimation experiences. So last year, me and my students and colleagues wondered, can the robot help since it can move, see, and talk with the user? After months of engineering and evaluations, we came up with the PepperPose framework, a nice and easy to implement robot system for active pose estimation and future embodied interactions. This framework only has 3 modules. It first captures the pose of a user with its visual system and open source algorithms. The pose data on one hand can be the input for downstream tasks. On the other hand, will drive the robot to move to the better viewpoints for improved pose capturing. Therein, the second module classifies the pose and retrieve the prior knowledge about the corresponding viewpoint for pose estimation. Finally, the decision-making module plans the route and moving behavior of the robot to approach the viewpoint. Particularly, this module is firstly trained in a simulated environment using reinforcement learning and RT algorithms with the action data we collected beforehand. And then the robot is deployed with a simulated-real deployment. To enable this framework, we collected diverse action data with our customized suits integrated with IMUs in a home-like environment. The data was used to train the robot in simulation using Omniverse. I have to say this environment is ideal for human-robot interaction training, as in our case, the animated avatar was well captured by the same set of pose estimation algorithms. We also built the prior knowledge in this space in terms of the impact of different view angles on pose estimation accuracies, and also for the changing distances between the camera and the user. This information proved to be very sufficient in helping the robot understand the actions it should take when the user moves and acts diversely in the open space. To evaluate the performances, we built this home-like space with essential everyday components like chair, yoga pad, sofa, plants, desk, and even bed. We compared PepperPose with RGB and depth cameras put at different angles. And during experiment, the participant is instructed by the slides projected on the wall. Apparently, PepperPose offers better pose estimation accuracies when the user moves and acts freely in the space. It should be noted that for fair comparison, the frames where the robot has noticeably interfered with the capturing of other cameras are manually removed. And furthermore, the track losing rate of PepperPose is comparable with those static cameras, which are all pretty low, in fact, and it can find and move to the better viewpoints within just a few seconds. And in the future, by improving the hardware and software as well as the software of the AC robot, we can even provide a better tracking experiences in terms of these two metrics. In terms of the use of such a robot in people's everyday life, we conducted interviews with our participants in terms of the acceptability, usefulness, their expectations, their trust, and the preferences, as well as their concerns about this kind of robot. Well, most of them shared positive opinions towards having a robot for their diverse needs. The detailed interviews we conducted revealed pretty interesting points, like some of them expect the robot can act as a personal coach to teach them new exercises, and some express their preferences of using robots instead of human, given the lower socializing nodes they would have, especially for those introverted person. And please continue to refer to the paper for more interesting details about people's diverse opinions for future human-robot interactions. And here goes the demo.
A significant challenge encountered with vision-captured mocap systems is the occurrence of occlusion, which arises due to the varying facing directions and actions of the user. By building with the mobile visual robot, PepperPose actively tracks the user and refines its viewpoints for better estimation results. This innovative approach mitigates the limitations of stationary cameras and many wearable-based methods, allowing users to move freely and act diversely in an open space. In our real-world experiment involving 30 diverse participants, PepperPose demonstrated superior performance over the wide-angle RGB camera baselines. It also performs significantly better than the Kinect DK depth camera with its official pose tracking SDK, which was easily affected by the distance between the user and the depth camera as well as the changing orientations of the user. With the same PepperPose system, the following demo was created with an extra high-resolution camera attached to the robot. Beyond the initial testing environment, the efficient framework design of PepperPose enables it to operate seamlessly across diverse scenes without requiring additional training or engineering. Consequently, we can envision PepperPose serving as a versatile and mobile action sensing platform in a variety of scenarios. Furthermore, PepperPose unlocks the potential of utilizing a visual system for contextual sensing. For example, the objects and scenes a user is interacting with, providing valuable data for downstream tasks. Looking ahead, we anticipate the further development and application of PepperPose in various fields such as remote rehabilitation, childcare, long-term health monitoring, and more.
And thanks